So this is the first of 4 lessons on the rules that govern how we name chemicals. So in grade 10 we cover the nomenclature of ionic compounds, and then in grade 11 we extend that a little bit more and go into a bit more detail and learn about how to name acids. So we're going to start with some pretty simple stuff this year and build on that. So as I've said before, it's going to be really important for you at each stage to really master the rules and understand the rules as we go through it and work through the practice. The practice is going to be essential for you to ingrain these rules into your mind. So, first off, let me say that the rules that we're learning are what are commonly referred to as IUPAC rules, okay? And that IUPAC is an acronym that stands for International Union of Pure and Applied Chemistry, and that is the organization that essentially decides, if there is a new chemical that is discovered or created in a lab, then IUPAC sort of governs how that gets named. If there's any new isotopes of an element that are discovered, then the new atomic mass for that element has to be calculated, and IUPAC would be covering that. So first let's just talk about the periodic table. It's going to be really important for you to distinguish between whether the compound is comprised of a metal and a nonmetal or 2 nonmetals. And so here's my quick reminder to you about this little staircase line that separates the metals on the left from the nonmetals on the right. And of course the metalloids are sort of in between. So for the purposes of this course, we're going to consider any elements, any metalloids that are on the left of the staircase, like polonium, antimony, germanium, etc. We're going to consider those for our purposes to be metals. And any metalloids that are on the right-hand side of that staircase line, we're going to, for our purposes, consider them to be nonmetals. Okay, so now I'm going to zoom in here on oxygen, just to point out to you that, and I'm not sure whether you've noticed this or not, but each element, whether we're talking about the main group elements or even these transition metals that we've really not talked a whole lot about, what you will notice in the upper right-hand corner is the common ionic charge for that particular element, which is why it's very important for you to have a periodic table with you as you're working through this unit. And that's a tool you'll always have access to, whether it's a quiz that we're writing or it's an assignment that you're completing. Okay, so that common ionic charge is there for you to refer to as you're working through the next 4 lessons and in any other circumstance where you may need to know that ionic charge. Okay. Okay, so we're going to talk next about binary compounds. Okay, and so the word binary, that prefix bi means 2. Okay, so binary compounds are compounds that are composed of only 2 different types of atoms. And so they're the simplest, which is why we're starting with them. And this year we're going to learn about 3 different types of binary compounds. We're going to look at the binary compounds that are composed of monovalent metal and a nonmetal. I'm going to talk a little bit more about what monovalent means in a minute. Multivalent metal and nonmetal compounds. Again, going to talk about multivalent metals and what the difference is between a multivalent metal and a monovalent metal in a minute. And lastly, we're going to talk about molecular compounds and learn the rules of naming those. And as we've seen before, we know that molecular compounds are composed of 2 or more nonmetals in general, but in this case, because it's a binary compound, it will only contain 2 nonmetals. Okay, so first let's talk about the difference between a monovalent metal and a multivalent metal. Let's look at these prefixes. Mono is a prefix that in science means 1, and multi, well, that's a prefix you've probably seen outside of science, and it means many or more than 1. And so that's exactly what, and that hopefully will help you to understand the difference between monovalent and multivalent metals. So valent is, that's a suffix that might make you think about the valence shell, and it's certainly related to that. So what a monovalent metal is a metal ion that only has 1 possible charge, whereas a multivalent metal is a metal ion that has more than 1 possible charge. I'm going to give you a couple of examples from your periodic table, and then we'll go through a few more just to make sure that you're clear on this really important idea. Okay, so what I've got here is I've zoomed in on aluminum on the periodic table, and this would be from the same one that I gave us as a handout for the class. And I want you to find aluminum, and I want you to note that it has this 3+ there. So notice that there's only one possible charge that's indicated there. Okay, so that is what's telling me that aluminum is a monovalent metal. I'm going to juxtapose that with iron. So when I look at iron on the periodic table and find it, its atomic number is 26. What you'll see is that instead there are 2 possible charges for iron as given by this periodic table. So given that, I would say that aluminum is monovalent, 1 possible charge, whereas iron is multivalent. It has more than 1 possible charge, and in this case 2 charges. So what I want you to do in the next bit is I want you to identify and say to yourself, well, are each of these metal ions monovalent or multivalent? This is a really important concept for us moving forward, and so take the time to make sure that you understand it completely. So I want you to start with silver, and it has the chemical symbol Ag. So pause the video, try to find silver on your periodic table, and when you do, identify it as monovalent or multivalent. Okay, so when I find silver, atomic number 47, I can see that in fact it has only 1 possible charge. So that is what's telling me that silver is monovalent. Okay, let's try that another time with copper. So find the element copper. It's located in the transition metals. Pause the video and identify if it's a monovalent or a multivalent metal. Okay, so when I take a look at copper on the periodic table, I can see that copper has 2 possible charges. So because it has more than 1 possible charge, I can say that it is multivalent. Next, gold. And gold is a transition metal, so I want you to look in the transition metal area and try to identify whether gold is monovalent or multivalent. So finding gold on the periodic table, I can see that gold has 2 possible charges, making it multivalent. 1 more to go. So zinc, lastly. So when I look at zinc on the periodic table, it's a transition metal, so it's important for you to know that not all transition metals are multivalent. Zinc is an example, and so is silver. Those are examples of transition metals that are monovalent. And I can tell that because zinc can only have a 2+ charge. When you get to grade 12 chemistry, we'll talk a little bit about why it is that some elements are able to exhibit more than 1 charge and others are not. Okay, so the first category that we're going to look at are compounds containing a monovalent metal with a nonmetal. So I want you to get used to when you have your periodic table in front of you and you're given the name of a compound and you have to create its formula or vice versa, what I want you to do immediately is to look and see, well, if it is a binary compound, what 2 types of elements is it made up of? And if it's a metal-nonmetal compound, then you're going to want to see, is it monovalent or is that metal multivalent? Because it has a bearing on how you choose to name it. Let's go through some examples. Okay, so we've covered what monovalent means. If you would like to write that down in your notes, here it is. Okay, so in naming, this is the naming rule that we're going to learn here. So in naming, the metal ion keeps its name, okay? And I should let you know that the cation always goes first in the formula, okay? Always. So the metal ion will keep its name, and the nonmetal will change its ending to "-ide". That's it. That's all there is to it. So in cases where you look at the formula for a compound, okay, and I'm going to give you an example, like NaCl. I can see that Na on the periodic table, if I find that element, it's in group 1. All elements in group 1 have a common ionic charge of +1. it is monovalent. So this rule that we've just learned applies here. Okay, so I'm going to apply that rule. The first part of the name is going to be sodium. And then all I do is I change this chlorine atom's ending to "ide." So putting those pieces together, this would be sodium chloride. Okay, so again, remember the cation will go first in the formula and the anion goes second, and I change that ending to "ide." Let's try a couple more. So MgF2, I want you to take a minute and see if you can name this compound yourself, and then we'll take it up. Okay, so I want you to also, we've only learned one set of rules, but we will be building on this, so I want you to build some good habits from the get-go. So I first of all see that magnesium is a metal and fluorine is a nonmetal based on where they're located on the periodic table. And so magnesium is monovalent, which means that the rules that we've just learned apply here. And so the name for this is going to be magnesium fluoride. And you may be saying, but what about this 2 here? Well, that 2 is only there because we've crossed that down because it's the most common charge on magnesium. So that does not play a part in our naming whatsoever. Okay, we just name it as is, and we don't worry about that 2 there. That is simply there because, as we learned in the last couple lessons on ionic compounds, that rule is there because of the crossover rule. Okay, let's take a look at another example. Li2O. Okay, so I want you to take a minute to name that. So again, you might be thinking, well, what about this 2 here? Why is that there? Well, you know, the name you should have come up with lithium oxide again, okay? And lithium being a group 1 element, and then I changed that oxygen to oxide. So if you said oxygenide, then you've got the right idea, but you know, typically the correct way of saying the anion of oxygen would be the oxide, so we would go with that. Now, let me just explain to you why this 2 is here real quick. Okay, so I know from the periodic table that lithium has a +1 charge, and I know from the periodic table also that oxygen has a -2 charge. And so I'm going to just cross those charges over as we've talked about. Right? And so that charge will go down there and this charge will go down there, and then I get Li2O. So that is why that 2 is there. And so it doesn't really play a part in the name because it's simply there because of the charges on the cation and anion that are making up this particular compound. Okay, let's go on to the reverse situation because, you know, more often than not, you're going to be, and especially I'm thinking about in grade 11, what you're going to have to do is do the opposite of that, which is I'm going to give you a word problem in words, and you're going to have to take the name of a compound and make it into a formula. That is a more common direction. And this we've already done. We're just going to use the crossover rule as we have before if you're given the name of a compound. So you just have to really know those ionic charges. If you happen to know the trends, fantastic. This year, those ionic charges are given to you in the periodic table. Okay, so remember, in this case, we're looking at naming monovalent metal, non-metal compounds, and so it is an ionic compound, and so we are most definitely going to be reducing to lowest terms if it's possible to do that. So let's look at a couple of examples, and this will reinforce what we've already studied together. And so just think of it as extra practice. So calcium chloride. So take a minute to come up with the formula for calcium chloride. Now, in previous lessons, I would have just said, well, what is the formula for the compound formed between calcium and chlorine, right? So now the wording changes slightly, and what we're telling you is just find the formula for calcium chloride. So I'll go through this first example, and the next 2 you can do on your own. Certainly pause the video if you do want to try this one. So the first thing I would do is I would go ahead and I would locate these elements and their ionic charges on the periodic table. Okay, so calcium has a charge of +2, And chlorine as an ion becomes chloride, and that will have a -1 charge. And again, remember, cation, positively charged ion, is going to go first, and the anion is going to go second. Okay, so then we're just going to cross those charges down, and that will give us Ca1, Cl2. Just like in math, if I had 1x, that 1 isn't necessary, and it's typical in science that we would remove that 1 and simply leave the formula written in its proper way as CaCl2. Okay, and I can see that there's no need to reduce anything here to lowest terms. It is already in its lowest term ratio. Okay, take a minute to try and get the formula for sodium phosphide. All right, so I started by looking up the chemical symbols for sodium and for phosphorus, and then I'm indicating their most common ionic charge. And then I just simply take those charges, ignoring whether it's positive or negative. I'm just taking the value of the charges and simply crossing them down and making them subscripts for the new compound that forms. Okay, and when I do that, anytime I have a 1 here, I can just eliminate that 1, okay, because when there's no number written, it's understood to be 1. And if there's an opportunity to reduce to lowest terms, then I will, but in this case, that is not possible. Okay, so hopefully you did okay with that. If not, absolutely reach out on our all-day Zoom meeting for some extra practice or help if you need it. Let's try one more practice question. Okay, this should be C, by the way. I'm noticing a typo, but no big deal. Magnesium oxide. Give that a try. Okay, so again, I found magnesium and I found oxygen on the periodic table, and I assigned each of them their most common ionic charge. And then I take those charges and I simply cross them down. But now I see that the ratio is 2 to 2. And a ratio of 2 to 2 is the same as a ratio of 1 to 1. So I'm going to go ahead and just change those to 1 and 1. And because they're 1s, I'm just going to eliminate them out because, you know, MgO is understood to mean Mg1O1. Okay, so that is it for now. What I want you to do is go to our week plan and locate the worksheet that will help you to practice knowing how to name compounds that contain monovalent metals and nonmetals in binary compounds.